Sharing the screen here, hopefully. All right, so here we are. Okay, so welcome to September. We're September now, September the 1st, I guess. So time's flying by. Okay, I was pretty much done with 1.7, so I can get started with 1.8. And hopefully, if I finish everything by tomorrow, then Thursday I'll make it a question and answer period. So if you can think of questions from any section, then please bring it up Thursday before the exam this coming Friday. Reminder, Monday's a holiday, Labor Day, so I think it's a good time to have the exam. It's on Friday, and then you have the 3-day weekend, and we don't meet again until Tuesday. Is that right? Okay, and how many questions are on the exam? I usually give about 10 questions. Okay, so minimum 1 question per section. So we have 1, 2, 3, 4, 5, 6 sections from 1.2 to 1.8. We're not doing 1.5. There is no 1.1. So I'll give 1 question from each section probably, and maybe another one from most of the sections. Okay, so my tests tend to be about 10 questions. That's not a promise. Maybe if there's a real long problem, I'll only give 9 or even 8. But if some questions are fast, maybe I'll give 11 or 12, but in the neighborhood of 10. Okay, and I'm making other changes. Some of these I don't remember if I've given to you or not, so please note all these other changes. So 1.6, I don't think I told you to skip 73B, 71B. So here's all the skips now. So from 1.6, skip 6, 55, 67C and D, 69B, 73B, 71B. These should all be in the recording. So when you get the recording, the video later, you should have that. 1.8, we're doing 45AB. That's not meant to be a skip. That's what you do. 45 has A, B, C, D, and a lot of other stuff. This means only do 45 A and B, and then skip 37. Okay, and once again, you turn all of this in on Friday. Please don't turn it in before Friday. I mean, I mentioned you can turn it in early. I'll take it anytime Friday, morning before class. So if you have it already, so I want to just get it over with, you can email me your homework at, I don't know, 7 a.m., 8 a.m. Okay. Remember, I put on the Canvas announcement, you have until, what, half an hour after class. So when class is over at 9 o'clock, I will close the Zoom. Then you have 5 minutes to take a picture, just get your cell phone and click, 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 all your pages. I've got to have it by, 10:05. And then you have to turn in the homework by 10:30. But again, if you already have it all done, then just give it to me ahead of time. Okay. All right, there's actually one problem I wanted to show you back in 1.6. So let me go back to 1.6, the racetrack problem, which was number 71. Okay, and this is on page 54. So 1.671. Noticing with this new computer, the print is a little bit better. It's not perfect still, but we'll try. Okay, a 1-mile racetrack is to be built with 2 straight sides of length L and semicircles at the end of radius R. Okay, and typical racetracks are like this, although most racetracks that you run aren't a mile, they're usually a quarter of a mile, but this is a 1 mile. So you have a straight part, then you run a semicircle, we call it R, and then this is another L, and this is another R. So the grand total is 1 mile. Okay, express the area enclosed by the oval as a function of the radius R, and we're skipping 71B. So we get 71B. All right, so let me switch over to this here. So I've got this picture of the racetrack. So we have R, radius, there's another R here, and the straight part is considered L. Okay? I want you to notice that if this is R, the distance from here to here is 2R, because this is a radius, this is another radius. Okay? So how do I figure out the L, which I've written up here, but let's work it out. So first, a little review of some formulas from geometry. If you have a circle of radius R, the circumference formula is 2 pi r. Circumference is 2 pi r, and the area was pi r squared. Okay? Again, if you want to sneak that into your cheat sheet for the test, you may. Okay? Circumference is 2 pi r, area is pi r squared. Okay, so let's imagine we're running or walking along this track. We go here, semicircle, here, semicircle. Agreed? Okay, now, I hope I can convince you of this. When I do this curved part, and then later this curved part, right? The two combine to be one full circle. Will you grant me that? Because I'm doing half a circle here, right? And then I'm doing the other half there, so I'm doing one full circle. And then I have an L here and an L here. So 1 mile is equal to 2 L's, the straight part, top and bottom, plus 2 pi r, the formula for the circumference of a circle. Okay, because again, imagine I'm running or walking. I got an L here, I got an L here, half a circle here, half a circle here. So if you count this part and this part, I've done a full circle whose circumference is 2 pi r. And then the two straight parts, 2L. So 1 mile, they said it's 1 mile, is 2L plus 2 pi r. Okay, I'm going to try to get an expression for L because they want a function only in terms of r. The original question was, express the area enclosed by the oval as a function of the radius r. So my answer can only have the letter r. So I need to get rid of L. Okay, so I have this. 1 mile is 2 L's, in the top and the bottom, plus 1 full circle. Okay, subtract 2 pi r on both sides. So I get 2L. I put the left on the right and the right on the left. Since I'm solving for L, I put the 2L there. 1 minus 2 pi r on that side. Then divide both sides by 2. So this is an expression for L. L is equal to 1 minus 2 pi r over 2. And that's what I put way up at the top here. That's 1 minus 2 pi r over 2. This is the same as this. Okay, so these two that I'm pointing at are the same. All right, now I want an expression for the area. So the area is this rectangular part. Okay, and how do you find the area of a rectangle? It's just length times width, or you can say base times height. And then I have one full circle, because I have half a circle here and half a circle here, right? So if I want the area, I got half a circle, full circle. Okay, so the area is pi r squared. Okay, so what is this weird thing I put here? That's 2 half circles. So I'm trying to write down here 2 half circles is 1 full circle. That says 1 full, and then I put an oval, which means 1 full circle. Okay, you got half a circle there, half a circle there. So for the area, I write the formula for circle, which is pi r squared, and then plus length times width. Okay, so length times width. We said the width was 2r, and the length is this funny expression, 1 minus 2 pi r over 2. Okay, so here's the length. That is the straight part. Parentheses 1 minus 2 pi r divided by 2 times the width. It's 2r because here's a radius, here's another radius, so 2r. All right, a little bit of cleanup, cancel the 2's. So pi r squared plus parentheses 1 minus 2 pi r times r. That would be an acceptable answer, or you could also distribute. If you distribute it out, that's perfectly fine also. But I'm just going to leave it like that. So that's my answer for 71. Okay, so I was pretty much done now with 1.6 and 1.7, so I'll start doing 1.8. Okay, so 1.8, which is on quadratic functions. So I have to show you some stuff in the text. So let me get you that right now. Okay, so 1.8 is on quadratic functions on page 63. Okay, so quadratic functions in general look like this. Y equals f of x equals ax squared plus bx plus c. We don't allow a to be 0. Okay, so linear functions only had this, bx plus c, or we can say mx plus b. But now we're adding a squared term. That's what makes it quadratic. Okay, the graphs are parabolas. So you know, for instance, y equals x squared looks something like that. Okay. Now, a little bit of notation, and you definitely want to get used to this when you get to calculus. So we're giving you a preview now in pre-calculus. Okay, that arrow means approaches. Okay, so arrow means approaches. So x squared approaches infinity as x approaches infinity. That means when x gets big, x squared also gets big. And x squared approaches infinity as x approaches negative infinity. That means when x goes way out that way, the y values also go up really high, approaches infinity. Okay, so you say x approaches infinity. So when you see this symbol, we say x approaches infinity, or you could say negative infinity. So approaches, A-P-P-R-O-A-C-H-E-S, approaches. X approaches infinity, or x approaches negative infinity. Okay. On page 64, here are some rules for horizontal shifts of graphs. Okay. That means you can take a graph and move it to the left or to the right. Okay. Top of 64, if you look at the blue graph, that's just x squared. The red one, they graphed x minus 1 squared. So how does x squared and x minus 1 squared compare? It looks like you took the blue graph and moved it 1 unit to the right. Okay, so the vertex is the bottom or the top of a parabola. You probably heard of vertex. We'll talk more about that later. V-E-R-T-E-X. And you can write it down now, but I'll talk more about it eventually. So the vertex, the turning point is 0, 0. It moved over to 1, 0. Okay. Notice what happens when you plug in 1 here. Plug in 1, you get 0. So the vertex is 1, 0. Okay, so we have these rules for horizontal shifts. It's in the book. If you need it, put it on your cheat sheet. If you have the original graph of f of x and you make it f parentheses x minus c, where c is positive, that shifts the graph c units to the right. And as you might guess, the opposite. If you change f of x to f parentheses x plus c, that moves the graph c units to the left. That's a little bit counterintuitive. Okay, I mean, the first time I learned this, if I saw the minus, right, I might have thought, oh, minus means you're going to the left, but it isn't. You're actually going to the right. And similarly, if I saw the plus, I would have thought, okay, you're going to move to the right, but instead you're actually moving to the left. Okay, if you want to put this whole thing on your cheat sheet, you may. But if you replace x with x minus c, shift to the right, c units. If you replace x with x plus c, you shift to the left. Okay, and I'm trying to show you some examples of that. Okay, so if you look at the original graph, the blue one is the original graph. That says f of x. If you can't see that, that's f parentheses x plus c, where c is some number. That shifted the graph c units to the left. So see, it's like you pick up that whole blue thing, move the whole graph c units to the left, and you get the red one. Horizontal translation. By the way, sometimes it's called translation. That's an acceptable English word for translation. I know usually when we think of translation, we talk about translating foreign languages, right? Like translating English to Spanish or French or Chinese or Russian or Arabic or whatever. But one English, you can look it up in a dictionary. One definition of translation is to move something left, right, up or down. Okay. So in this case, the original graph was the blue, f of x. They made it f parentheses x minus c. If you can't see that, it's f parentheses x minus c. That moves the whole graph c units to the right. So they took that whole blue graph, moved it c units to the right, and they call it a horizontal translation. Okay? So horizontal translation means move it left or right. Okay, now let me show you the vertical shifts. And this is on page 66. This moves the graph up or down. So suppose that c is positive. The graph of y equals f of x plus c moves the graph up c units. And that, to me, follows your intuition. If I see the plus, I would think, okay, it's up. And f of x minus c moves the graph down c units. Now, unfortunately, these aren't on the same page, but I try to show you the difference. Hey, that kind of looks like the horizontal one. Well, for the horizontal one, the x minus c and the x plus c, the whole thing was inside the parentheses. See how it's different? It goes f parentheses x minus c or x plus c. Okay, but for the vertical shift, the plus c or minus c was outside of the parentheses. It was completely separate. See how it's different? Then that gives you a vertical shift. So they write it like this: f of x plus c, that's c units up. F of x minus c, that's c units down. Okay, and they call this a vertical translation. Again, translation means move up or down. Okay, not the translation meaning translation of a language, but translation means move up or down. So the original blue graph, f of x, and then if you can't read it, that says f of x plus c, move the whole graph. It's like you pick up this whole graph, move it up c units, like 2 units or 3 units or whatever. Here with the original blue graph, f of x, they move down c units. So just shove the whole thing down c units. So y equals f of x minus c. Okay, then we have the rules for f of x equals ax squared. And by the way, we're only looking at ax squared. They could add an x term and a c term. So in general, it could look as bad, quote unquote, as this: ax squared plus bx plus c. The shape of the parabola is completely determined by the a coefficient. The b and the c aren't going to tell you anything about the way the graph turns, like up or down. It's only the a. And I think some of you have heard this before. So we only look at ax squared. If a is positive, the graph opens upward. If a is negative, the graph opens downward. So positive a, like x squared, 2x squared, 5x squared, 1/2 x squared, they go up. If a is negative, like negative x squared, negative 5x squared, negative 2/3 x squared, they all go down. Okay? I'll come back to this in a second, but I want to show you top of 67. Okay? So you should already be somewhat familiar with these. Y equals x squared. If you can't see it, this is your famous y equals x squared. Y equals negative x squared. Okay? Positive a goes up, negative a goes down. Now, in both cases, we will call the vertex 0, 0, V-E-R-T-E-X. We'll talk more about it later. This is the vertex. The vertex on this parabola looks like it's the lowest point. So if you have a parabola which opens up, the vertex is the lowest point. But if you have a parabola that opens down, the vertex is the highest point, V-E-R-T-E-X, vertex. Now there's the word vertex right there, V-E-R-T-E-X. We'll get more of that later. So if you don't write it down now, that's okay. We'll get it eventually. Okay, now what's all this saying? So there's that arrow stuff again. Arrow means approaches. And we're setting you up for the language of calculus. Okay. In calculus, you'll see this arrow over and over and over again. So by the time you take calculus, you'll get used to that arrow. Then you say, oh yeah, I know that arrow means approaches. Okay. So if a is positive, f of x approaches infinity as x approaches negative infinity, and f of x approaches infinity as x approaches infinity. So what does that mean? That means when x gets big, y gets big, essentially. And when x becomes a large negative, y is still going to be a large positive. So x squared, if I plug in 1,000,000, y is real big. If I plug in negative 1,000,000, since I'm squaring it, it's positive, so y will again be very big. And what is all this about? If a is less than 0, negative, f of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches infinity. You say, huh? What does that mean? That means when x gets big, y becomes big negative. Okay, so think of negative x squared, right? If I plug in 1,000,000, you have negative 1,000,000 squared. So a million squared is a big positive, but the negative in front of the whole thing will make it a big negative. So it drops down to negative infinity. And likewise, I would plug in, let's say, negative a billion. Negative a billion squared is positive big number, but the minus in front of the whole thing would, again, make it negative. Okay, so that's what all that means. Okay, and here they're showing you different coefficients. If you can't read it, that's okay. But just the general idea, you've got x squared. Looks like you got 2x squared, 3x squared. Okay, positive coefficient. They're all going up. Okay, these all have negative coefficients. So the blue one is negative x squared. They also sneak in here negative 2x squared, negative 3x squared. They all go down. I guess they have some fractions here. So the blue one is x squared, half x squared. So it kind of widens out more, right? And 1/3 x squared is even wider, but it's still going up. And likewise, negative x squared is the blue one, and negative a half x squared kind of comes out wider, and negative a third x squared is still wider, but they're still opening down, as you can see there. Okay. All right. This section, again, we'll come back with a quadratic formula. On page 70, you have the quadratic formula. You should already have it memorized, but since I've already said you can have a cheat sheet, you can put the quadratic formula on your cheat sheet in case you've forgotten it. You should have it memorized, though. And by the way, your next teacher in calculus, I'm guessing, is going to have you memorize it. Frankly, if we had met face-to-face, if we were meeting on campus face-to-face, I would make you memorize it. But we're supposed to make things easier on you guys because, you know, we're in a tough situation in COVID and all that stuff. So maybe in that sense, you're fortunate that you're taking me this semester because I'm letting you have the cheat sheet, but ordinarily I wouldn't. Anyway, here's the quadratic formula, right? If you have standard form, ax squared plus bx plus c equals 0, a is not allowed to be 0, then you have this, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you should already know that. Put it on your cheat sheet if you want to. Okay. All right, so I think we're ready to start some of the homework problems. So 1.8, once again, we have 1 to 41 odd, 45 only do A and B, and skip 37. Okay, and let me shine that for you again. So page 73, for those of you who never want to get the text. Okay, it looks like the image comes out a little bit better with this new computer, so that kind of helps. So that's the top part. Up to about 21, so I'll show you the bottom there now. Okay, that's that. And then looks like page 74. There's some more. So up to 36C, I guess. So a little bit further down. And bottom. Okay, then page 75, some of that, so up to 41, so a little bit lower, and still lower. And I think that's it. Oh, yeah, you see 45. 45 has what? A, B, C, D, E, F, G. So you only have to do A and B. And I believe that was it, right? So yeah, 45 was the last one. So that is that. Okay, so I'll get started with some of these problems here now from 1.8. Okay, sketch the graph of the given quadratic equation. Okay, so switch over here. Number 3, 1.8. Okay, again, skip whatever I put for the dates. Y equals negative x squared plus 1. Okay, so you should know negative x squared. And by the way, you should get somewhat comfortable with plotting these without plotting points. You shouldn't have to make a table. Okay, so you know x squared opens up, U-shape. Negative x squared opens down. Okay, and do you recall what's the effect of having plus 1? Plus 1 moves the whole graph up 1 unit. So there we go. So here's a quick and dirty graph of y equals negative x squared plus 1. Okay, so if you can watch what I'm tracing with my pen, if I graph the U shape like that, right, that's x squared. Negative x squared would be traced out like that, And then negative x squared plus 1 is like that. Okay, so this is the highest point. It's called the vertex. The vertex is like the turning point. It's the highest point if a parabola opens down. The vertex is the lowest point if it opens up. So this is also the vertex, and the next one is I want to show you. Okay. Here are some key points: 0, 1, negative 1, 0, and 1, 0. Okay, you can get that by just plugging in. If you plug in 0, you get 1, right? If you plug in 1, negative 1 squared, that's negative 1 plus 1 is 0. Same thing for negative 1. Okay, then number 7. I already put the answer there, but pretend you didn't see it. Quick and dirty graph of x plus 1 squared minus 1. X plus 1 squared minus 1. So your base function is x squared. You should know x squared is your parabola opening up. Okay. And now I see that and that. So what's the effect of changing x to x plus 1 and this minus 1 outside? Okay, so this x plus 1 moves the graph 1 unit to the left, and that minus 1 moves 1 down. Or we would say the translation. Translation is 1 left and 1 down. So the vertex, which used to be at 0, 0, if I move it left 1 and down 1, the new vertex is negative 1, negative 1. Okay, V is my abbreviation for vertex. Okay, so vertex. So then the vertex is either the highest point, if the parabola looks like that, or the lowest point, if it looks like that. So we only use the word vertex for parabolas right now, so we don't use it for straight lines or other shapes, at least not yet. Okay, so I just put negative 1, 1. I know it opens up because I have a positive coefficient for x, so it goes like that. So quick and dirty graph goes something like that. How do I know this parabola opens down? It goes down because I have a negative for a, negative x squared. Okay. All right, negative 11 is, I'm sorry, for problem 11, it's a little bit harder. I was going to say there's a negative there. Okay, so how do I graph this? Okay, so y equals negative x squared minus 2x. Okay, what I need to do is make this equation look like that. Okay, the way I'm going to do that is completing the square. There's that completing the square business once again, half and square. Okay, you should have seen that before in algebra, hopefully. But before going on, quick note, does this parabola open up or down, and how do we know? Okay, it should go down because I have a negative coefficient of a, right? So it's going to be an upside down U shape, right? It's going to open down. That also means the vertex, is the vertex the highest point or the lowest point? Let me show you these two parabolas again. Will the vertex be the highest or lowest point? Okay, if the parabola opens down like this one, then you know the vertex is the highest point. If it opens up, you know the vertex is the lowest point. Okay, so how do I do completing the square? Okay, ignore the red temporarily. So pretend those reds aren't there. We have to do half and square again. So the process of completing the square, take half the coefficient of x and square it. Okay, so the coefficient of x is 2. So how much is half of 2? 1. So this is the half part. And then after that, I do the square part. What is 1 squared? It's 1. Okay, so now I put the plus 1 right here. And by doing that, this becomes a perfect square. But when I write that plus 1, it's kind of deceiving. You're not really adding 1. Because there's a minus there, you're actually subtracting 1. Okay, so if I subtracted 1 to balance it, I have to add 1. Okay, so the net result is on the right-hand side, from here to here, I added 0. And that gives me an equivalent expression. Okay, so if you look at the difference between this and this, I wrote the stuff in red. All the stuff in red combined to be 0. So it's legal. It's a legitimate operation. I've not changed the value of the expression. I subtracted 1 right here, negative 1, and then I added 1. Negative 1 plus 1 is 0. So I get an equivalent expression. It's a little bit tricky. You have to account for that coefficient. Okay, again, if you're not sure, multiply this all back out. Do I get the same thing? I get negative x squared, right? Negative 2x, there they are, minus 1 plus 1, which cancel out to be 0. So yes, it is the same thing. All right, so if I do it the right way, this now factors into a perfect square. This is what squared? It's x plus 1 squared, if you recall from the algebra. Which is one of the reasons why you spent so much time in algebra doing factoring. Remember, you did factoring, factoring, and more factoring. It's so that you can get comfortable going straight from here, hopefully, to here and say, oh yeah, that's x plus 1 quantity squared. So now it looks like this, negative x plus 1 squared. Okay, so again, there's a negative. Does it go up or down? We know it goes down because of the negative. And now what's the translation? What's the effect of changing x to x plus 1 like that? That moves the graph 1 unit to the left. And what's the effect of the plus 1? That moves the graph 1 up. Okay, so left 1, up 1. So the vertex used to be the origin. I go left 1, up 1. So the new vertex, which I'm abbreviating V, was negative 1, 1. And then I know it goes down. So just make it look something like that. Okay, so again, that was completing the square. Okay, so we are taking advantage of these rules. So let me go back and show it to you again quickly. For horizontal shifts, F parentheses, and the whole thing is in parentheses, right? If you go x minus something, you move it to the right. If it's x plus something, you move it to the left. The whole thing's in parentheses. Okay, the vertical shift is if the plus or minus is outside the parentheses, and then plus means you go up, and minus means you go down. Okay, so that's what I did over here, right? So when it looks like this, parentheses x plus 1, that's 1 left, and then this plus 1 means 1 up. Okay, I'll do another one which is a little bit harder because of the 1/2 there. Okay, and yes, you already see the answer, but let's pretend we don't see it. 1/2 x squared minus x plus 3. Okay, first, which way do you think this parabola opens, up or down? And how do we know? It should go up because A is positive. Okay, so it's going to be U-shaped. Okay, so it's going to be something like this, and therefore the vertex will be the highest point or the lowest point. It'll be the lowest point because it's opening up. Okay, now for this one, the first thing I have to do is factor out the half. I'm going to complete the square. Again, I have to force this equation to look like this. Okay, in order to do it properly, I have to factor out the half. If I take out the half, okay, it's actually going to look like this. And that seems a little bit confusing. But notice how I changed the negative x to negative 2x. Running out of pens here. Okay, it's almost like saying, okay, I multiplied by a half, so to balance it, I have to quickly multiply by 2. Okay, I know that sounds weird, but if I take out a half, how do I get it back to this? I multiply by 2. And maybe if you don't understand that at all, you can double check by multiplying it out. What do you get when you take half times that, right? What's half times x squared? Half x squared. What's 1/2 times negative 2x is a negative x. So it balances. And there's the plus 3. And there's something behind my 2 pens there in just a second. That's completing the square. Okay, so one more time. I factored out the half. So to balance it, I have to multiply this thing by 2. Okay? Or you can think of it as I divided by 2 and then I quickly multiply by 2. Okay? So you know what that balances. Okay, I have to lose these 2 pens, but pretend they're not there. Now I complete the square again. Okay, so I'll try to cover it up again. So take half the coefficient of x and square it. That's half and square. Half and square. So how much is half of negative 2? Negative 1. Square it. Negative 1 squared is 1. Okay, so inside the parentheses, I'm putting plus 1. If I factorize that, it's going to be a perfect square. But just like the previous problem, because I put a half here, I'm not really adding 1. Okay? What am I really adding? It's a combination of this and this. So how much is 1/2 times 1? Well, 1/2. So I haven't really added 1. I've added a half. So to balance it, I now have to subtract a half. Okay. So one more time. That +1 was needed by completing the square. So completing the square gave me the +1. But because there's a coefficient of a half in front of the whole thing, I haven't really added 1. I've really added a half. So to balance it, I subtract half. That way, again, on the right-hand side, what did I do? I added a half and I subtracted a half, which means I've added 0. And if I add 0, I get an equivalent equation. Okay. Again, double check. If you temporarily ignore the red, this is 1/2 x squared, right? That is negative x, 1/2 times negative 2x, negative x, and plus 3, right? So temporarily ignore the red, I have the original. Now, if I put the red stuff, +1 minus a half, that +1 is really plus a half. So that times that is plus a half minus a half, that's 0. So I do get the equivalent of the original. So I know it's a little bit weird, kind of convoluted. Okay, so factor this, x minus 1 squared. Okay, again, quick shortcut, when you see something like this, all you need is the square root of this. What's the square root of x squared? Well, x. Just need the square root of this. Square root of 1 is 1. And you keep this sign. Now, this one's always a plus. But if this one's a minus, this one's a minus. If this one's a plus, this one's a plus. Okay, 3 minus a half is 2.5, or 5/2. So I finally got it. So my equation, this is equivalent to 1/2 parentheses x minus 1 squared plus 5/2. Okay. So I take the original parabola, which goes through the origin, translate 1 to the right, 2.5 up. So I go 1 to the right, 1, 2.5 up. So the vertex, which used to be 0, 0, is now at 1, 5/2. And there we go. Okay, that was certainly a much harder problem, as you can see. Okay. All right, then I think I'll do 21. And maybe I'll stop not much after that. See. Okay, a quadratic function is given. f of x equals negative x squared plus 4x plus 6. Okay, so 19 and 21 are similar. 19 is easier because you have a positive, so I'll do the negative for you. Okay. And find any intercepts and find the maximum or minimum value of the function. Okay, so the maximum or minimum will be the vertex. Okay, so before I tackle 21, which way does this parabola open? It's going to go down because of the negative. Okay, so it goes down. It's like that and not like that. So will the vertex be the maximum or the minimum? The negative means it goes down, so the vertex is going to be the maximum. Okay, if the parabola is going up, then the vertex would be a minimum. Okay, so here we go. Negative x squared plus 4x plus 6. Okay, factor out the negative. Okay, if I factor out the negative, it's parentheses x squared minus 4x. And here's the plus 6. Okay. It's almost like the previous one where I took out the half. If I took out the half to balance it, I have to multiply that by 2. Here, if I take out the negative, I have to compensate by making that one also a negative. Okay. And again, maybe the easiest way to think of it is multiply that stuff out. Okay. So negative x squared minus a minus 4x plus 4x. So right now, do you agree it's the same as the original? Right? Negative parentheses x squared, that's negative x squared, minus a minus 4x, there it is, and then plus 6. And then what about these two pens here in red? That's where I complete the square. Okay, so I take half the coefficient of x and square it. Okay, half and square. Half and square. Okay, so half of negative 4, negative 2. Square it, 4. So I put plus 4 here. That completes the square. This is now a perfect square. But there's a negative in front of the whole thing. So by writing the symbols plus 4, I've really subtracted 4. So how do I balance subtracting 4? I have to add 4. Okay. Quick inventory check, as it were. Let's multiply this out. Negative x squared, there it is. Minus a minus 4x, that's plus 4x, there it is. Plus 6, there it is. And then the new stuff in red, minus 4, these two combined is minus 4 plus 4. Minus 4 plus 4 is 0, so I got it. It works out. Okay, so now this factors into negative parentheses x minus 2 squared. Okay, easy way to factor a perfect square, just put the square root of x squared, which is x, put the square root of 4, which is 2, and keep this sign. So negative parentheses x minus 2 squared, and then plus 6 plus 4 is 10. Okay, so where's the vertex? The vertex used to be 0, 0, but that means I move 2 to the right, 10 up. So 0, 0, move a 2 to the right, 10 up. The vertex is 2, 10, which means the maximum value is 10, because I already know the parabola goes like that. Okay. If the parabola was opening upward, then I would say the minimum value is 10. Okay, then part B asks for intercepts. Find any axis intercepts, x-intercept, y-intercept. Oh, we already did C, find the maximum or minimum value. We got it. 10 was the maximum. Okay, intercepts. That means plug in x is 0, y is 0. Well, if you plug in x is 0, that's easy. Put a 0 here, that's 0. Put a 0 here, that's 0. Right, negative 0 squared, well, 0 squared is 0, negative 0 is 0. 4 times 0 is 0, so 0, comma 6. The harder one is to plug in y equals 0 for x-intercepts. So 0, remember f of x is like y. So 0 equals negative x squared plus 4x plus 6. Okay, usually you don't like the leading coefficient when you're solving with the quadratic formula to be negative. So easy remedy, if I have 0 equals that, multiply both sides by negative 1. Okay, I always advise making the leading coefficient positive. Okay, so multiply that by negative 1, multiply that by negative 1. Negative 1 times 0 is still 0. Negative 1 times all this means change the sign, right? So it's going to be positive x squared minus 4x minus 6 equals 0. Okay, so throw it into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. A is 1, understood. B is negative 4, and c is negative 6. Throw it all in. You've done this many times before, right? So here we go. X is negative b. Watch out for this. Negative b is negative negative 4, so it's a positive 4. Plus or minus square root b squared, negative 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 6. Okay, pretend that's a minus. I know I changed it. Minus 4 times 1 times negative 6 was a double negative. So negative times a negative makes it a positive. And so I like to make them both pluses. So it's a plus. 4 times 1 times 6 is 24. So scratch paper here, I have 16 plus 24, which comes out to be 40. So 4 plus or minus the square root of 40 all over 2. And remember doing this in algebra. Okay, how do you break down 40 into a perfect square times something else? 4 times 10. Now you say, what about 5 times 8? 40 is 5 times 8, but neither 5 nor 8 is a perfect square, right? I can't do anything with them. Likewise, what's wrong with 2 times 20? Neither 2 nor 20 are perfect squares, so you want 4 times 10. And then the next step, the 4 will come outside because I know the square root of 4 is 2. So it looks like that. And then just divide the 2 into both of these. 4 divided by 2 is 2. 2 radical 10 divided by 2 is just radical 10. So I have 2 plus or minus radical 10. Right? So for the x-intercept, writing it as points, you have 2 plus or minus radical 10, comma 0. Those are your x-intercepts. Remember, x-intercept means y equals 0. And by the way, don't punch in your calculator. Okay, square root of 10, I did it before. It's like 3.16 or something like that. But just leave it like this. So 2 plus or minus radical 10, 0, and the y-intercept is 0, comma 6. All right, and I think that'll do it for today, folks. So I will shut everything off and turn off the recording. And do that here. Okay, and let's see. How much time for exams? Yeah, I told you the exam ends at a normal class time, so class ends at 10 or pretty soon now. Then I turn off the class, and then you have 5 minutes to take a picture on your cell phone and submit it to me, and you have until 10:30 to submit the homework. Okay, and let's see. Anybody else with something quick? We're just about out of time. Okay, you can always send me an email or catch me during office hours if you want. Okay, I think that'll do it for today, folks. So everybody have a good day, and we'll see you next time. All right, bye, everyone. Thank you.